Here is another example to find the relative maxima and minima of a graph. Find the maxima and minima of f of x is equal to 1 over 4 x to the fourth minus 1 over 3 x cubed minus 3x squared plus 8. Then sketch the graph. So to find the maximum and minimum, we're going to find all of the points that make the derivative of the function equal to 0, or it makes the derivative undefined. Here is the derivative of the function. Please make sure that the derivative is correct. Then we're going to make this derivative is equal to 0 because we want to find every point that makes the derivative is equal to 0. Notice here that I don't have any points that make this derivative undefined. I don't have any denominators. I don't have any radicals. So I will jump straight to making the derivative is equal to 0. Now I have an x here and I have x squared here and I have x to the third here. So I have 3 here and I have 2 here and I have 1 here. I can pull one x out as a common factor. So that is going to be the answer. When I pull x out as a common factor, I will be left with x squared minus x minus 6 is equal to 0. Now I'm going to factor this part because it is a quadratic function. So I can factor it into x minus 3 and x plus 2. I have 1, 2, 3 roots in this case for that quadratic equation. So I'm going to solve for x's. If I put x is equal to 0, I will get x is equal to 0. If I put x minus 3 equal to 0, I will get x is equal to 3. If I put x plus 2 equals to 0, I'm going to get x is equal to negative 3. So basically, I will have 1, 2, 3 critical values. Then I'm going to find the critical points by plugging x is equal to 0 in the original function. So plug x is equal to 0 in the original function and then find f of 0. Plug x is equal to 3 in the original function and plug x is equal to negative 2 in the original function. So if we do that, we're going to get at f of x is equal to negative 2, we're going to get y equals to 8 over 3. So the first critical point is negative 2 and 8 over 3. The second critical point happens at 0. So we have, if you plug 0 into the original function, you're going to get 0 and 8. If you plug 3 into the original function, you're going to get negative 31 over 4. So we have 3 critical points. Now, those 3 critical points are dividing the domain of the function into 4 intervals. So we start with the smallest point, which is negative 2, and then 0, and then 3. Notice how those points create 4 intervals. The first interval from negative infinity to negative 2. The second interval is from negative 2 to 0. The third interval is from 0 to 3, and the last interval is from 3 to positive infinity. We need to test all of these points to see the behavior of the function on these intervals. So we're going to create a sign diagram or a table. Here is the table. It has the intervals, all of the intervals that we created using these critical points. We're going to choose testing points from these intervals. So I want to choose a point that is inside of the interval negative infinity to negative 2. Negative 3 seems to be the biggest number there that I can use, and it's easy to use. I'm going to choose a number between negative 2 and 0. The only integer between them is negative 1. I don't want to choose fractions, of course. And I want to choose a point between 0 and 3. The point that I'm going to choose is 1. It's small enough to work with. And I'm going to choose the last point between 3 and positive infinity. I'm going to choose the smallest integer, which is 4. Again, next we're going to plug these testing points into f prime of x and see the value. So if you plug negative 3 into f prime of x, the answer is going to be negative 18. Please make sure that is correct. And then if you plug negative 1 into f prime of x, you're going to get 4. If you plug 1 into f prime of x, you're going to get negative 6. If you plug 4 into f prime of x, you're going to get 24. Meaning this is a negative, this is positive, this is negative, and this is positive. Again, I don't care about the exact numbers. I care about the sign of those numbers. Then we're going to look at the conclusion. The conclusion says that f prime of x is negative. That means the function is decreasing on this interval, on the first interval. F prime of x is positive. That means f of x is increasing on that interval. f prime of x is negative, that means f is decreasing on that interval. F prime of x is positive here, that means f of x is increasing on that interval. So if we sketch a little diagram just to show which point is a relative maximum and which point is a relative minimum, we will get the following. Notice how it is decreasing. So I drew a line that is decreasing, reaching to the first point, which is the first critical point, which is -2 and 8/3. And it is increasing on the second interval from -2 to 0. And then from 0 to 3, it is decreasing. And then from 3 to positive infinity, it's increasing. That will conclude that this is a relative minimum, this point is a relative maximum, and this point is a relative minimum. Now we use the previous information in order to sketch the graph. You will notice that I plotted all of the critical points. I plotted the first one, the second one, and the third one. So basically that is the graph that I drew. It's going down and it goes up and then it goes down. So this point is basically -2 and 8/3, and that point is 0 and 8, and that point is 3 and -31/4. And here I'm just sketching it as if I'm going to graph the actual function. You will notice that the function is decreasing on the interval from -infinity to -2. So from -infinity to -2, the graph is decreasing. That means I am expecting it to go this way. And then from -2 to 0, the graph is increasing. And then from 0 to 3, the graph is decreasing again. And from 3 to positive infinity, the graph is increasing. So if I want to sketch this graph, it might look something like this. So if I connect the points and sketch the graph, it might look something like that. Again, this can be just a sketch. You don't have to be precise when you're doing that step.